Good morning, everyone. Welcome to this 20-second ETP4HPC webinar. I'm Pascal. I'm ETP4HPC's communication manager, and my colleague Mike is also here to help run the show. And I will introduce the speakers and panelists later. So today's topic is our SRA 5, and we will focus especially on the topic Federating HPC, Cloud and Data Infrastructures. So for those of you who are not familiar with ETP4HPC, I'm sure there are not many of them, but we are a non-profit association that promotes European research and innovation in HPC. We are a private member of the EuroHPC JU, which is the organization in the European Commission that addresses HPC, and our role is to propose research priorities for Europe in the area of HPC, and that's exactly what this webinar is about, the research priorities we identified. So, sorry. So I have a few practical information for you before we start. This webinar is recorded. You will receive the link to the recording tomorrow. This webinar is in listen-only mode. Only the speakers can speak, but you can use the webinar, the GoToWebinar control panel that's illustrated here to ask questions or to download handouts. So there are two handouts today for you. The slides, they are available in the handouts section, so you can have them right now. And I have also put there the PDF version of our SRA 5. It can be downloaded here or from our website. So concerning questions, you can submit questions at any time during the presentation. I will share them in the chat so everybody can see them, and we'll handle them at the end of the session during the Q&A session. Yes, I think that's about it for practical information. So let's see our speakers. So we have two speakers today and two panelists. So let's start with the speakers. So Michael Malms first. He's our SRA expert. I often describe him as the grandmaster of the SRA. So you will have information about the SRA straight from him. And then today's topic will be covered by Dirk Pleiter, who is a professor at KTH and director of the PDC Center for HPC. And we also have two panelists, if I can move to the right slides, yeah. We also have two panelists today. Andreas Wieser, he's the managing director of SICOS, and Utz-Uwe Haus is head of HPE's EMEA research lab, and both of them heavily contribute to the SRA and to today's topic. So we are very happy to have them for the Q&A session. They will be able to add more, to give more information about this and answer your questions. So this is today's agenda. I'm done. So I will hand over to Michael. Michael, I will invite you to share your slides.
Okay, can you see them?
Not yet.
I cannot, I'm not enabled yet, Pascal. I press the button and there is a sound coming back, so I'm doing something I'm not do.
You are presenter.
Yes. Okay. Now something changed. Okay. Okay.
Sorry about this. We did practice.
Yeah, we practiced.
Oh, here we are. Now we can see your slide.
It was on the other screen.
Sorry, everybody.
So sorry. Okay, good. So then, thank you. I don't plan to go into the same level of detail as last time because this will be boring. I only would like to talk about two charts or three charts. Yeah, The SRA number 5 is ready since quite some time, and we do a kind of introduction round now with these webinars. There are more webinars to come. We've had one on I/O last time. We also decided, Pascal, to print quite a number of these documents very soon. So either you download this now, you read this on the screen, or you might in the next foreseeable future also have a chance to hold one of these issues or one of these books in your hands. So SRA 5 in numbers, this is the most comprehensive one that we ever did, 160 pages. We have added 2 more working groups, one on quantum computing and one on unconventional HPC architectures from SRA since SRA 4. So we have 10 working groups now. We have 25 working group leaders and more than 120 contributors. So today it's all about talking about a so-called cluster. And last time we talked about a so-called research domain. The difference between the two is that a domain is a level of the certain area of the HPC stack for the most part. And these clusters are topics that are of special interest at a certain point in time. So the topic of federation is extremely interesting. It's extremely important these days, because now you have more and more division of, you have cloud and data and HPC infrastructures, several sites who are not being viewed as singular entities anymore, but as sites that share data, share compute, and how to orchestrate this so that this is efficient. This is all part of the federation aspect. There's more to it, as you will hear in a second. This topic of federation is extremely important also for the ETP, since we are now in a kind of consultancy mode to Destination Earth. You heard about this TCI activity. So the ETP is heading this consultancy action over the next 20 months. And we just started a few weeks ago. The discussions are going on. We're supposed to write white papers here. There will be one and very central one on federation technologies mapped to Destination Earth. So stay tuned. You will hear more about this topic. This here is to underline the importance of this topic for the ETP and I think for the entire HPC community. So this is all I wanted to say today. Pascal, we can turn this over to Dirk now.
So, yes.
Thank you very much. Today the system is a bit slower. I also seem to have the same problem as Michael.
We can see your slides.
Oh, okay. Oh, that's interesting. So you also can see it now changing?
Yeah, you're on slide 2.
Okay, excellent, excellent. Because I didn't get a menu to actually select, so that this has behaved a bit different than before. Okay, so also a very warm welcome from my side, and I will say directly start here with the second slide, as it gives me the opportunity to introduce the full team of authors which have been involved in writing this white paper, which also point reference here, and which was been made public in April of this year. So Uwe Haus from HPE and Andreas Wiers from Cycross has already been introduced to you, and they also say part of the panel to answer your questions after this presentation.
Dirk, sorry to interrupt. Can you speak a little bit louder?
Yes, yeah, and also apologies from my side. I'm not in the expected environment where I thought to be 15 hours ago, but I'm currently in an airport lounge, so I hope it will work. So also involved in this effort was Saina Hamuti from Seagate and Maria Perez from UPM. And I can say reconfirm that was a very nice effort in putting this all together. So I will, in this presentation, start with giving you a bit of background, and in order to make things a bit concrete, present, say, selected initiatives. So where do we stand today? And as the strategic research agenda is in particular about identifying, say, areas where research and development should happen, in this white paper, we looked into a number of what we call then topical areas for research and development, which we consider being important for realizing these future federated infrastructures. And based on that, we also came up with recommendations for future research and innovation efforts. So let's start with the background. And what I think is a very important thing to realize when we think about federated infrastructures is that this is going in line with changing needs of existing user communities as well as the needs of new and emerging science and engineering domains. And a very important aspect is here the support of collaborative research, the need for having wider access to HPC-enabled higher-level services. So we should not only think about, say, what I would call the classical HPC user, which logs in and then through a shell submits a Slurm job, but may then, for instance, access these kind of services through web-based interfaces. We start to see that connects also to the ETP4HPC's TCI initiative, workflows which extend the HPC data center. So here we talk about the computing continuum, where then geographically dislocated services are being used. And that is very much also about how we interact in the future with research communities. We have to have the ability to deploy domain-specific platform services. So that could, for instance, be web portals, databases, etc. Now, at the same time, in order to respond also to these changing needs, I would argue that there is a change also in the way of how we will look at HPC data centers. Today, HPC centers mainly identify themselves that they operate one or a few big systems. But in the future, and this is, say, a process which we see already emerging, is that HPC centers are rather, say, operated as part of a federated e-infrastructure services providers, and where the services are based on different compute and storage resources that in particular also includes HPC, but it's not limited to HPC. Now let's look in some of the communities which have been asking for these kinds of changes. And one community is the brain research community. The Human Brain Project started almost 10 years ago and now resulted into an European research infrastructure which is called eBrains. It was accepted for the S3 roadmap in 2021. And it is really about providing services for a diverse and geographically dispersed research community that uses, say, a variety of methods. Right? And I just give you here, say, a few selected use cases. So we have also here, say, what you could still consider kind of more classical HPC. People are having, say, models of the brain network, and given, say, the complexity, in particular when it comes to the human brain, I mean, these are, say, model simulations that have to carry out on the largest supercomputers which are available. But at the same time, we have, say, other researchers which are doing, say, very extensive data processing, for instance, image processing of brain images. You need to use machine learning methods in order to, say, process these images. So also here we have, say, high demands as these are, say, potentially, say, petascale data sets. But then we also have, say, the request for having, say, interactive computing so that you can look at these data sets in a more interactive manner. So you need to have access to petabytes of data, but not necessarily a large compute power at the same moment. And there is also, say, the wish, I mean, to deploy, for instance, a science gateway, which in this context is called a collaboratory. Now, Michael mentioned already, say, Destination Earth, and for me, this is another good example of where we see an upcoming need for having, say, a federated infrastructure, because things will not be located at one site. But clearly, when it comes to weather and climate simulations, we do have a need for, say, HPC being involved in that. And there's another aspect which I would like to highlight in this context with one of the use cases which have been published in the context of Destination Earth. That's accelerating disaster risk management. because here we are not only talking about, say, the more, say, classical, say, HPC users coming, for instance, from academia, but it might also be, say, expert users or advanced users coming from public authorities. So people which have, say, are otherwise not exposed at all to HPC, and which, of course, are also not interested in getting exposed to the details of the HPC. And that's where we need to have, say, different ways of how we make HPC resources available. Now, when we talk about federation, it has, say, many different aspects, and that is sometimes a bit overlooked. I mean, obviously, there is this question about identity and access management. So if you are, say, a user which wants to access a service on one side, I mean, you should also be the same user when you access, or the same, have this with the same identity, more precisely, be able to access service at another side. Now, this also requires, for instance, an harmonization of policies for how to manage access control, but also of how to manage identities, of how to make sure that you also, say, are compliant with, for instance, when it comes to questions like nationalities, which, like this year, also with this, after the war in Ukraine, became more, say, relevant for HPC centers. But when we look at resource federation, there are a number of other challenges where I would also claim we are not yet, say, fully there. How about, say, centralizing the resource allocation mechanism? We are very much used to doing it on a per site basis. And how can we then account for this on a federation basis, and maybe also get to the point where we have a centralization of the resource procuring? So where for some workloads, you might not care and where it's actually being executed. Then obviously we need to have a good network connectivity, but there's also the question about how do we establish a trust federation. So if something is trusted on one side, for instance, an identity is also trusted on the other side, or vice versa. To what extent can a user trust this? Then there's this wide field of interoperability between services, and to what extent do we have a need of really having, say, common APIs, both towards users as well towards system administrators. And there are a lot of other policy questions, like also, for instance, federation of service level agreements, in particular when we think about, for instance, destination Earth, where there are, say, very strict requirements when it comes to certain quality and the delivery of data products. Still, I mean, even so, we get a lot of complexity. There's obviously, say, also, say, benefits for federating geo-distributed services. I mean, starting from, say, the opportunity to improve availability, because you can also, users can deploy then the services at different locations, and if one location goes down, then the service will be available at another location. It gives you the opportunity also to exploit data locality. So in particular, when we have, say, physics experiments, but also in the context of brain research, we have seen that very large data sets are being generated, and you don't want to move the data sets, but actually being able to move the compute on where the data is. It can also improve the accessibility of services and data, because you have the identity federation in place, and that makes it then easier to onboard more users. And it also gives you an opportunity, increasing, say, the diversity of services and resources, because it allows you to integrate in also more specialized computing facilities. So something which is, for instance, happening also in the context of e-brains, where there's neuromorphic computers in place. Now, I would like, I mean, also, say, acknowledging my background as particle physicist, also briefly mention that what we currently call a cloud, it has, say, a lot of roots back in what was called grid, and it was, say, introduced in a seminal paper in Forster and Kesselman in the late 90s, where they introduced it for describing a distributed computing infrastructure for advanced science and engineering. So it did have, grid did have a very science focus. But still, there are concepts also which came from there, which are very relevant as of today. I mean, for instance, the concept of virtual organizations. So you have, on the one hand, you have resource providers, which then interact with the virtual organizations. And you have, on the one hand, say, the federated resource providers. And on the other hand, you might have, say, global virtual organizations. Examples are, for instance, the organizations behind the LHC experiments like Atlas CMS, LHCP, or Alice. Now, key architecture requirement for having this virtual organization is that it's possible to establish a relationship between these potential participants, and then also the organizations which offer then the resources. And that is still something which is very valid when we think about today of how do we provide resources to research communities and research infrastructures like, for instance, eBrains, and the same will come up in the context of Destination Earth. Now, I would like to briefly also touch on this term cloud, because cloud is actually a very overloaded term. There are, in particular, 3 different meanings of it. You could refer to cloud in the terms of the cloud architecture, as it has, for instance, defined in the cloud NIST Cloud Computing Reference Architecture, which was published in 2011. But there's also cloud as a business model, right? That's what we, as I know, from the big public cloud providers. But here, when we talk about cloud in this context, we actually mean here cloud technologies. So that means technologies that have been developed in particular for realizing these public cloud infrastructures. So let me briefly take you through a few selected initiatives. One of them where I have been heavily involved in when I was early at the ULI Supercomputing Center is Phoenix, which started as 5 European HPC centers involved in the Human Brain Project, and then later CSC joined this effort. So it's now driven by 6 European HPC centers. And as already mentioned, it have been triggered by the Human Brain Project and its needs. So that's why I also introduced the brain research initially, as this flagship project was really, say, a driving factor behind Phoenix. Now, while it is, say, an operational infrastructure, so you can go to Phoenix and ask for resources, one important outcome of this was also, say, a conceptualization in terms of what is our, say, approach in also providing, say, compute and data infrastructures. And the idea is essentially take, and this is a point where I indeed also reference a bit to, say, the cloud as an architecture, where you have this very clear notion of having, say, multiple layers. Now, on purpose, we avoided here of not talking about an infrastructure as a service because it has a slight bit of a different meaning. But when we talk about an e-infrastructure services layer in the context of Phoenix, and that's the part which you see here in this picture here on the bottom with the more orange red colors. That's where you have a more hardware-oriented services which are federated, but it's mainly think about this as services which are not community-specific, so that as an data center, you keep a chance of having this manageable and not starting to become, as a fully domain specific. But at the same point, while you aim for serving multiple user communities, you allow them to then deploy their community-specific services, and that's what you see here in this green layer. And ideally allow them to have the services which you provide, say, at the bottom, composable according to the needs. So you try to be able to serve as many of the user communities as possible. Now, another abstraction which we introduced here was in terms of what kind of service do we provide, and that is largely split into 3 areas. It's the computing services, the data service, and the federation services. Now, the computing services, I mean, it still includes the classical HPC, here called the scalable computing services, but it also is extended due to the needs of the brain research community, for instance, having interactive computing services, but for instance, then also the more cloud type of services, here the virtual machine services. If we would have started Phoenix 2 years later, I mean, we would immediately have, for instance, also added here container orchestration services. And similarly for data services, here we introduce a distinction between, say, federated archival data repository, so that's where federation happens, but also because we have on our HPC systems, we do have a fast parallel file systems which are not suitable for federation. We also foresee, say, a different class of storage services, which we call then active data repositories. And then, of course, in order to facilitate the federation, you have to have AI services in place, and you have to be able to manage users and resources. And this is now a new service which has been developed in the context of Phoenix and is currently being put in operation, which is called Firms. Another aspect which was introduced in the context of Phoenix is to also think about, okay, we do have, and that's also what the prize have been established in the part, we have the HPC environment, which is very much, say, a silo and protected environment, as well as also say the cloud environment, which we want to have say open as possible, and that could have also been a grid environment, and that's what we actually have seen in the past. Now, however, what we have seen in the past is that these two environments are very much separated, and that it's very cumbersome of connecting one part with the other part. And one of the things we should try also to achieve with Phoenix is actually to have this integration of HPC and cloud, and that is mainly also facilitated to this already mentioned archival data repositories. Now, mentioning briefly a second initiative, Gaia X, because also in the context of Gaia X, there is the ambition of integrating also HPC services. It is, say, a much wider initiative, but which has been only established in terms of legal entity rather recently. But it has as a key deliverables architecture specifications. It also will have open source components for the implementation and instruments for certification. So it might at the end of the day not be so much of, say, a real infrastructure, but more an architecture specification within different implementations according to the different stakeholders throughout Europe. Now, a very interesting notion here is the conceptual model for, say, different participants, say, this split between, say, providers, consumers, and federators, which are then also responsible for different types of services, where you can also then, just using a different language, also make the connection then back to Phoenix. Now, let me switch now in the last part of this presentation to the topical areas of R&D, which we have identified in this group of people which have been involved in this white paper, and what are also recommendations which follow from that. Now, starting with the authentication authorization infrastructure, in particular when it comes to HPC, here we are not yet really there where I think we should be. And ideally, I mean, today we are having a situation where essentially, if you would use this more modern language, data centers act as their own identity providers. So the user gets there, gets an account, and that's where you have then your identity. Now, what we would like to get to in the future is that we actually, this identity management is then, say, in some sense outsourced to, say, a set of trusted identity providers, and that you have a common AI layer which allows you then to federate the multiple IDPs. And then you might need to have attribute services in order to augment, for instance, also attribute the information which you have on the different identities. That could also be information relevant for authentication, like for instance SSH keys. Now, here there's still, say, quite a number of technical challenges. I mean, the integration of, say, established authentication workflows like ORDC is not yet, say, fully there. We don't have, say, full support of the authentication mechanisms as they are used in the cloud, and it's also the policy questions like how do we, say, handle different levels of assurance. I mean, definitely you don't want to have people just with a Google identity to get on your HPC system. There is the question of how do we integrate multi-factor authentication, and how do we also improve actually our security levels if we, say, aim for a single sign-on, because then if one identity gets compromised, then there's of course a much higher risk and much more resources at stake. Now, one concept which say, essentially started, say, from Phoenix, but then also from Puri, so the AI service around Lomi, was then merged into what is now called the My Access ID concept, and which is now driven by Jean. And you can find here also this picture on this reference where you can find more information. But here I just want to highlight that this actually really shows about this this picture of that you have on the top. We have, say, a set of identity providers, and HPC Center might still continue to be an identity provider. And then you have a common AI services layer, so which these different IDPs are federated. And then different service providers can connect to this common AI services layer. And now the different services might still then be grouped, and this is where we introduced in the notion of infrastructure services domain, where you share a common policy, for instance, when it comes to resource allocation. So in the middle part, that essentially corresponds to the human brain part of Phoenix, and on the right you see here Lumi with the Puri proxy. A second area where, say, also further research and development more is needed is when it comes to integration of HPC and cloud-based computer data services. The challenge here is really of how do we connect the open, accessible, cloud-based and the much more protected HPC-based services. And there are very, say, real use cases which say are in need of that. I just took here as an example something which comes from the material science community, where in particular at EPFL they have been developing a software framework which is called AIDA, and which is really meant to have a set of services through which you can then also spawn HPC jobs. Now, so the solution strategy is here to have, for instance, then mechanisms for how to spawn predefined workflows. So you want to make sure that you cannot just do whatever you like on the HPC system. You need to have a certain level of control, and then have automatized and in particular also asynchronous data migration mechanisms, which allows you to move things back and forth between the cloud and HPC environment. Now, while there are solutions in place as of today, they are essentially in many cases largely custom solutions. So there's not really a fully established and easy to deploy solution which is widely accepted. And that's where, say, the development effort has to go. Let's move over to the area of resource management, allocation, and accounting. So what we see today, and that is of course this more classical HPC approach, that we have batch-oriented allocation of resources because we want to maximize the utilization of the hardware. On the other hand, if we look at, say, in different more emerging research areas, emerging in the sense of emerging users of HPC, then we see more and more often also the call for having more elastic resource allocation. There is, when we have then this more diversity of services based on a diversity of resources, also this question about how do we co-schedule these resources. When you have, say, concurrent execution of processing of data, data transfer, different storage tiers, and how can we, say, schedule, say, different workflow components which are then also executed in different environments. Think again about, say, these cases where workflows extend a single data center. So today we are typically standing at the point where we have resources being allocated for one system, and the future really has to be that we are able to schedule resources for multiple organizations which are allocated to a single project. Next topic, trust, security, and data compliance. Here we are talking in this federated setup about resources and services which are operated in different security domains. They are different at different locations. You also have different regulatory boundary conditions, and that is particularly, of course, critical when data gets transferred, because when you think, for instance, the classical example is here the transfer of personal data, where say GDPR compliance is very interesting if it's also then connected with local rules there. So you have a lot of things which need to be addressed both at the policy as well as at technical level. So, for instance, harmonized security levels. And that is really an area where I think there's a bit of a lack of standards. There are very few standards which really say, okay, I mean, if you comply to this and this, you can claim to have reached a certain security level. And there's also a need for having suitable mechanisms for establishing trust. And one example is here, really, when it comes to an end-to-end secure setup for workflow execution. I mean, how do I make sure that all parts of my workflow is really executed in a trustable environment? And is it then also possible to have then audit trails? A next topic, which is a long-standing issue, which also has had a lot of discussion in the grid context. How do I facilitate distributed infrastructure monitoring? So how do I make sure that the federated infrastructure, from in particular user perspective, is perceived as a single entity? And that means that if there's a malfunction or a performance degradation, you have to identify it in a short time, and ideally it's not identified by the user, because for the user it becomes too complex to actually understand, say, the interplay between the different components deployed at different geographic locations. And of course, the risk of chaos increases when you have several services being operated by different organizations. So here we also have an increased relevance of service level agreements, and also here we have to say still improve our understanding of how do we put it in place. And I did already refer, for instance, to the example of Destination Earth, where there are time critical services, time critical computations that are going to be done, and how do we get them on, say, more academic systems, so not dedicated systems as they are typically used today, as they are, say, operated within HPC. Next area, harmonization of service provisioning. As of today, I would say HPC centers are not always doing a good job in making it easy for the user. I mean, every HPC center, or many of the HPC centers, they have, say, a long history, and they have, of course, a long history of doing it in the best possible way. But obviously, there are often many different ways of how you can do things in the best possible way. And how do we actually here compromise and get, for instance, to a harmonization of the software environments? Now, there's various supporting technologies and technical solutions, for instance, tools for automated service deployment, also, say, lightweight virtualizations using containers can be very helpful, as well also tools for creating uniform and customized environments like Spec and EasyBuild. So I would say here, technology-wise, a lot is in place, but the main challenges remain here also at an organizational level, at least for the HPC part. And then, last but not least, the question about usability for end users. I mean, they are why we try to have, say, realize, say, benefits by a federated infrastructure. I mean, we cannot say ignore the fact that the architecture becomes more complex. There are interdependencies of different services. There are new types of services. It might become more complex of getting help. There might also then be issues with negative experiences due to the discrepancies between the ambitions in terms of what do we want to have in place and what do we actually are able to put in place. And what I often also notice is that in the communication and the training office, there's not always a sufficient good distinction between, say, different types of users. Now, there are various, say, approaches for improving usability, which we also, say, described in this white paper. So, for instance, to establish DevOps for federated e-infrastructures, so that we have, say, more people which have a good understanding of federated infrastructures. That we have service and resource selection support, that we have maybe also some intelligent optimization of knowledge and service work. We support the users in selecting their service, and also to create added value cloud services which are connected to HPC. So we are then opening up really new opportunities for users which otherwise would never have, say, done this step of getting onto HPC as it's perceived as too complex. So what are, based on that, our recommendations? So we have to, say, strengthen our efforts for integrating HPC system and HPC-based services in a federated e-infrastructure, and really aim for, say, commoditization while respecting also, of course, the need for, say, security, and the even growing need for security, I should emphasize. It's also about improving the accessibility by integrating, say, different types of services, both on HPC as well as the data services. So how can we, for instance, make services available through web-based APIs, and support also the data transfer between HPC systems and different data platforms and data lakes. We have to improve our support for centralized resource allocation and resource consumption, so that people don't have to knock on the door of different service and resource providers, but that you have essentially the vision of having a one-stop shop. We have to improve our collaboration between HPC and cloud communities for research and innovation on orchestration. This is a very hard problem, and so that is definitely an area where further research is needed, which then hopefully translate into usable solutions. We have to improve the support for end-to-end secure setup of workflow executions, which typically is not something which is really possible, and where you can really, say, fully trace what is, where are the different components of a workflow being executed. We have to establish standardized interfaces for collecting, monitoring information, so that we have always a good overview of what the state of the federation and not just of individual services. And finally, to promote the usability of by end users, for instance, by establishing DevOps as a profession and with the suitable skills. So let me summarize and conclude to leave time also for questions and discussion. So there are, say, a number of initiatives towards realizing federation of pan-European infrastructure services, and that is really important to serve the future needs of different research communities, which are really addressing very interesting challenges. And I think both what one tries to achieve still in the area of brain research, but also in particular, say, this very new area of establishing a digital twin for the Earth is super exciting, and that is really also encouraging to work down this road of federation. But it needs also to have support for researchers and developers to deploy domain-specific services, because that's where you put also researchers into a kind of a new role. So it's not just, say, the data centers which act as service providers. And there are many, say, challenges which remain both at an organizational and policy level, but there's also a number of technical challenges and a lot of room of research and innovation, and we only, say, discuss in this white paper a few of them. With that, I thank you very much for your attention, and we three are very happy to receive your questions and comments.
Thank you, Dirk. Thank you for doing this presentation in a fairly distracting environment. Must be difficult for you. So we already have questions coming in, but I thought maybe before we get started on the questions, maybe our panelists would like to comment on what you said. Uwe or Andreas, did you have anything to add? Or can we start on the questions?
What I might add is my personal perspective from what CCOS is doing is very much on industry use of HPC. So the SRA, of course, is much wider, but I see several aspects here which are really critical and important for industry, especially. So so that ease of use, for example, this is something that industry is really looking on, not because it's easy to use, but because it's a cost-benefit thing. Yeah? If it's easier to use, the resources of the brains of the engineers can be put into, well, they can just work more. So there are many things there that are especially important for industry.
Right.
Thank you.
So now if we start with personal statements like that, I have to take one from my two roles, one being at HPE, where it's clearly the ease of use for our customers, which are the centers, of implementing any of the requirements that in my second role as a researcher and co-author here, we put on the list of to-dos at the end of Dirk's talk. HPC systems are too difficult to manage, to expect all the different requirements that individual sites have regarding local policy, regarding local country or user community requirements, to implement all of that in such a way that we can scale that and use it at different sites. So that's clearly one of the big steps in the way that I see. And now I think we should go for questions.
Yeah, thank you. But I mean, Dirk had been doing all the talking, so I thought it was fair to give you the opportunity to talk too. So we are starting to have questions. So we have a first question from Ovidio Marco. I think he's from the University of Luxembourg. It's for you, Dirk. So the questions, I copy them all in the chat. So just have a look at the chat and you will see the questions. So regarding slide 23, are you familiar with the skycomp.org initiative, the sky above the clouds? Can you comment on the need for data orchestration for workloads deployed over cloud or HPC? Do you see data transfer on the critical path to federating HPC cloud infrastructures?
Okay. Well, I mean, we have looked at different initiatives, and as say highlighted earlier, I mean, this was we say just selected two for this white paper, also mainly because we did have expertise within the group of authors on these two initiatives which were presented here, and this is not to not acknowledge to say the important work which is done in other initiatives, also the ones which you are mentioning here. Now, let me briefly say connect to this question about, say, how critical is this data management. I think the answer to this question depends very much on which, say, community you are looking at. So at least the communities I've been exposed to, and that, for instance, connects includes the brain research community. It also includes the for instance, Destination Earth, so the weather and climate community. But we have been also looking at the different EOS science clusters, and at least in some of them, data transport plays a very critical role. And for instance, also the ability of being able to move data in and out of the HPC center is a very important one. So just to give you an example from, say, a more different area. So some of the discussions which we did have with the ESCAPE EOS Science cluster, where you have the high energy particle physicists, but also the radio astronomist, is, I mean, they are working hard on, say, putting data infrastructures in place. So it's basically modernizing, say, the existing grid data infrastructures into, say, data lakes. But also the way of how the computing needs to develop in this area, both in terms of the simulations which need to be done, but also in terms of the role of machine learning. There are, say, an increasing amount of HPC requirements there. So these research communities really would want and have a need to use HPC. Now the question is, how do I get the data from these data lakes into the HPC centers? And that's again where we don't have really good solutions in the sense of these being, say, fully deployed in the infrastructure, right? I mean, we do have the technologies, but we don't have, say, the infrastructures at a point where I think it's really satisfactory for these kind of research communities. And then maybe also to highlight another community that's, for instance, the photon research community, because there you also have the other demands when it comes to the availability of the systems, as they have this more bunched say, availability of data, which then has to be quickly processed as it comes out of, say, a synchrotron or a free electron laser.
Thank you. Thank you. Now we have a question from Manolis Maratsakis from Force. Hi, Manolis. Thanks for this excellent talk. Can you comment on the topic of integrating HPC and data services, in particular the concept of data lakes, and how to enable user-submitted workloads to use data sets available in such environments? Who wants to comment on this?
Well, I can take that, and I'd like to combine it actually with the next one from Joachim.
Okay.
Because, I mean, at least partially, maybe the others will then pick it apart again. One interesting aspect that we all know in the HPC community is that we've talked about data sets too big to move as needed for a long time. And so the fact that we have data available in one HPC center and maybe other parts relevant for the same research question in others is where the data lakes come from. And we do have them effectively. However, people have to manually often manage access of parts of their workflow to the individual data sets. And that's where the abstract APIs that Dirk had in the slides on submitting work to data centers without knowing all the details about how to get the right queue, how to optimally run your job there when you're not used to that, come into play. Because if you have this API level abstraction, all you care about is where is my data? Maybe even that is not relevant for you anymore, and some middle layer can decide where to run the job or whether to move the data because there's 10 other users requesting the same. And GaiaX could be, if implemented properly, the federator for that. Because what you can offer on GaiaX is data services that includes advertising which data under which access rules is available to whom and how to gain access to it. And in GaiaX, we have this picture of data providers, compute providers, the federating entity, the end user, and your jobs can move from one of the other through this network of federated resources. So if we manage to advertise the data available in the abstract data lake of, let's say, European data centers or Euro HPC data centers, if you want to be smaller, that could be a good entry route. The difficulty is that GaiaX at this point regarding HPC centers is a bit blind. That's why what I meant by if it's implemented properly. But it could be the path to that. Most of these data sets are either open and so even attractive to showcase what can be done on GaiaX, or they're open to a certain science community, which is almost as good because it's reasonably easy to check access rules. They're not to be monetized. which is another aspect that needs to be sorted out for data lake access to data which has a value per use. And then we come into interesting technical discussions. How do you bill single, double, triple use of the same data set in such a data lake? But let's not go there today. I don't know if that answered the question from Joachim properly, but it's at least one thought I have on this.
Okay. So can we go on to the next thing, which is a comment really from Gergely Sipos. I'd like to mention the recently published HPC integration handbook from the EGI Federation that provides solutions for several aspects that have been mentioned. Integrated AI, I guess, resource allocation and SLA's several higher level services over cloud plus HTC plus HPC, monitoring of distributed resources, and you have a link here. Anyone wants to comment on the comment? No?
Before I said earlier, I mean, that's why I also trying to stress that we say just did a few selections, and probably, I mean, if that's this work of the EGIA's project would have been published earlier, we would definitely would have quoted it also in the white paper. But that was already more or less completed at the beginning of this year.
Okay, so now you have the link for anybody interested. So let's get to the next question. We have lots of questions coming in. Question from Fotis Nikolaidis. Congrats for this insightful talk. I would like to ask how you envision the physical networking between data centers. Will that be dedicated high bandwidth, low latency networks like most cloud providers do, or will it be internet based? Who takes this one?
Well, I can take it. I would say it depends, as always. Of course, there's a cost issue related here, and on the other side, it depends on the need that you have. And I think there are many applications where, well, where we are talking about distributing them. So if you have a distributed computation with some decent communication in between, then you need low latency, high bandwidth. Otherwise, it doesn't make sense to distribute it. But if we are talking about, let's say, a single system runs where data transfer happens offline, of course, it will be the cheapest way, the best, the cost-benefit ratio will be different, and internet-based can be an option because it's taking place offline. So I wouldn't expect a clear, let's say, a single way only. I would see a combination of these.
Same
Okay.
here. I mean, what maybe went unnoticed to some people in one of the early slides of Dirk for this paper is a discussion on geographically distributed redundancy for HPC centers. And in that case, you probably want the low latency configuration, pretending they're all one center. But for federating existing big sites like in EuroHPC, it's really a cost issue in the end, whether you can do dedicated links between, say, Chinica and Lumi. It's going to be a separate discussion. And they're different owners, so it's also a question of how tightly integrated you can be at the high performance interconnect level.
Okay. So now we have it's a comment more than a question from Gerd Büttner. Hello, Gerd. I fully confirm Dirk's view on data security and data distribution. It is a key topic for industrial users, potentially quite different to academia users, less critical.
I would add something or create a link. As we all know, EuroHPC joint undertaking, they are kind of, well, they are distributed systems all over Europe, and they want to attract industry to a significant share. So it's true that academia is a little bit more relaxed, but also that depends on the topic that you have. So if it's about climate change, it's probably not critical. If you're developing new pharmaceutical things, it might be completely different. But in order to get industry on these systems, the security level has to be up to industry standards. So if they want to do it, they have to do it for the systems, which means that also the academia will have, well, to deal with it and work with it. And it's going to be interesting to see how this goes forward, because it could give the whole thing a big push, making things more, how to say, well, standard. Yeah, you don't have to think especially of security. It's just there. So that might prove very helpful.
Okay, we don't have any more questions for the moment. Dirk, did you want to add anything, or Andreas or Uwe? I mean, the floor is yours. We still have 5 minutes.
Well, then I'll second Andreas' comment from just now. I think maybe one of the next items we should work on internally is to flesh out the secure HPC vision, which is implicit in the federation, as Andreas mentioned. And it comes with so many different aspects that are all mentioned in the federated HPC context. But you need to monitor users that you don't really know because they come in through the federated door in a different way. You need to maybe give access to their local authorities who gave them the credentials to be part of this, to monitor their jobs. Now you have external admins on your system. All of that is really out there. At the other time, you may actually need to protect the data of that user from other users on the system that they don't know, because they don't trust their neighbors anymore. HPC centers often are operated in a kind of colloquial way, right? Everybody knows each other, and there's a central social contract around users of one system. So now if you don't trust your research group next door, it's exactly the same as you would have it before with two industrial users on the system who don't want the competitor to know what they're running. And so there's different aspects of the same secure HPC question here. And in the cloud context, we either get our virtual machines that seem to be secure, or you go for fully encrypted environments on the cloud that you trust if you go that way. We're far from that in the HPC context in most cases, unless you get dedicated parts of a system. And so that's the outlook really on the federation. If we go federated, we have many interesting challenges to solve.
Thank you. Anybody wanted to add anything, or should we go to the conclusion? I don't see any
Maybe
more
just
questions coming in. Thanks for the seminar. We have special thanks from Joachim. Thank you, Joachim. So, Dirk or Michael, do you want to conclude?
I would like to thank Dirk and Andreas and Uwe for this great contribution. So again, pointing to the SRA, you have all the text, the important elements in there. There's also a separate white paper on federation. So wherever you go, which one of the two paths you would like to use, you get the information. And maybe a little bit about the next webinars. We plan to have other similar sessions in January and February. They're being worked on. So other topics of the SRA will be discussed and will be presented. So stay tuned.
Thank you. We have a last-minute comment from Ovidio Marco. Would be great to have an extended view from industry on these issues if more users are coming from that side. Thanks for discussion. So maybe an idea for a next webinar. Thank you very much for everyone for your participation. Dirk, did you want to say a last word, or?
Well, maybe just let me extend it to basically all authors of this white paper. It was really great fun to put it in place, and I'm looking forward to basically the proposed new white paper. I think it's indeed a very relevant topic, and I would also highlight stress here, it's not only say the question of the technologies, but it's also say a lot of policy questions there, and they are really worthwhile of writing them up. I mean, a lot of things have been done, also academia driven, and so that would be say a really good next step.
Good. Well, we're getting to the end of this webinar just on time. So unless anybody has anything to add, I will thank everyone. I will thank our audience for being here today and for asking so many questions. I think this presentation raised a lot of interest. We always see it from the questions, so that was good. I would like to thank our speakers, Michael and Dirk, and our panelists. It was really great to have several authors of this of the SRA and have several points of view. It's always interesting to see this at work. So as Michael said, we given the good feedback we had on those SRA webinars, this one and the previous one, we will organize at least two new ones in January and February. So I will send information to all the webinar attendees about this. And so I hope to talk to you again in January. And in the meantime, well, I wish you all an excellent holiday season. Enjoy, have a restful and peaceful holiday season, and talk to you in January. So thanks everyone, and bye-bye.
Okay, bye.
Thank you. Bye-bye.
Thank you. Bye-bye.